Now let's see how factory method can help us create instances of different classes here. So first thing we need to do is add a method here that will return instance of the product, and this method needs to be virtual. You can also make it pure virtual, that is your choice. If you make this method pure virtual, then remember you cannot create instance of the creator. And if you are implementing factory method in your class and that needs to be instantiated, then this create method cannot be pure virtual. It should be only virtual. So in my case, I'm just going to make it virtual and provide a default implementation. The default implementation will simply return null. Again, in some implementations, it might return a default product object, but that all depends on the kind of problem you're trying to solve. So this create method is going to be our factory method. Why? Because it will create instances of classes. And then instead of creating the instance like this, we will create the instance by calling the create method. And when we do this, we no longer need to include concrete product header file. So you see the dependency on this class is now gone. The only thing you have to do is include the base class header file so that we can at least invoke operation method virtually. Now we will add a new class called concrete creator. This will inherit from the creator class. It will override the create method. And in this implementation, we will return instance of the concrete product. Now, instead of creating instance of creator, since we need instance of concrete product, we will create instance of concrete creator. And when we invoke an operation, it will automatically create the correct instance. And you can see the call to operation of concrete product. Now, what if we need instance of concrete product too? What do we have to do? Just add a new class. Now we need instance of concrete product 2, so we'll create instance of concrete creator 2. Run it. And we have the call to the operation of concrete product 2. So in all of this, did you realize that we have not modified this code? So this method, create method, can return instance of any product class. Now let's compare this create with the call to the constructor of concrete product. When you invoke the constructor of a class, then it returns an object of the same class. When you use the constructor to create the instance, it needs the name of the class. And consequently, it will always return the same instance. So we can say constructor returns instance of a class. Think about this create method. Create method also returns instance of a class. So we can say it behaves just like a constructor. However, the instance that it returns is not always same. It can return instance of any class. So that is why we can say create behaves like a virtual constructor, because it can return instance of any class. Now, one thing you have to understand here is that the instance that is returned is not any arbitrary instance. It is an instance from a hierarchy of classes. So all the instances that are returned by create are parented by some common class. So virtual constructor is the alternative name or the alias of the factory method. And in C++, virtual constructor is an idiom and is frequently used when you want to create instances of classes without depending on their concrete types. Let me show you the class diagram of these classes. This is our creator hierarchy and this is the product hierarchy. So there is an operation in the creator method which needs to create instance of different classes from product hierarchy. So we have added the factory method called create, which is internally invoked by an operation. And this create factory method is overridden by child classes and they will return instance of a specific product class. So you see here, the creator class does not create the instance of the classes itself. Instead, it defers the instantiation process to its subclasses. And this is what factory method is all about. The factory method defers the instantiation process to its subclasses. Why does it do that? So that a class, that is creator class, can get instances of different classes without depending on their concrete types. Let's see the dependency between the classes. The creator class is just dependent on the product class. And it does not know anything about concrete product 2 and concrete product. So this way we have a complete flexibility of adding more products in this hierarchy. So I can add more products here. So we can have concrete product 3 and the creator class can still work with concrete product 3. All we have to do is just add a new concrete creator that will create instance of the concrete product 3. So this is concrete creator 3 and that will create instance of concrete product 3. We have seen the basic implementation of the factory method. In the next video, we will see a real-world example where factory method is useful. See you there.